Live. The speed is very low. Let's see if it works. Okay. Yes, exactly. I just need to know in the live chat, can you hear me and can you see me properly? Is it fine? Is everything fine? Yeah, hi. Okay. In the live chat, if you can see me and if you can hear me properly. Okay. Yeah, actually it was there were some communication issues, that's why. Internet problem and everything over here. Yeah, Yawar sir is back, exactly. Okay. Is everything fine? Can you hear me and can you see me properly? I just need to know in the live chat. All of you. Okay. If everything is fine, then it's very nice. Okay. Okay. So, ladies and gentlemen, boys and girls, this is me, Yawar Manzoor. Yeah. This is me, Yawar Manzoor, and I believe everybody of you is doing great. Okay. It's been a very long time since I took the last lecture, because there were some issues in my state. Okay, that's why it was the internet was completely blocked. I was not able to talk to anybody, that's why. So my name is basically Yawar Manzoor, and this is a piece of information about me. I'm a JEE Physics expert. You can definitely read it out from the screen itself. Okay, and today we're gonna be talking about the potential energy, understand, potential due to different charge distributions, understand everything. I'm gonna take, because this was the concept which was messing with my mind in my 11th or 12th class, okay, over there when I was basically preparing for JEE. At that point of time, this was a definitely hitting, messing with my mind, understand, because understanding that, getting the proper feel of this potential is bit slightly difficult. Okay, let me just give you that today, and we'll be covering entire potential energy, potential, and some of the beautiful problems at the end as well. Okay, in the beginning also. And before that, I need to basically tell you this. Apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform. Okay, over there you can take this plus subscription, you can take this iconic subscription. Okay, in this plus subscription you'll be getting live classes, structured courses, weekly tests, unlimited access. There are so many features that you will get in this plus subscription, because for sure country's top educators are working inside, they are teaching you inside this Unacademy only. So if you take this plus subscription or iconic subscription, you can watch anybody's lecture, any top educator's lecture, any damn time, understand, in a particular category. So that's why we say live classes, weekly tests, unlimited access, structured courses. And in this iconic subscription, you're gonna be getting all the benefits you get in plus, and there are some extra benefits as well. Like we have personal guidance. What is this personal guidance? Means you'll be given an educator who will be working with you throughout your exam. Understand? Whatever the doubts you have, he will clarify all the doubts. He'll give you the solution of all the doubts. Okay. And you'll be getting the test analysis once you are done with your test. After that, you need to analyze your scores, experts guidelines, study material, study planners. And afterwards, you can basically follow me on Unacademy. This is my username. We come up with so many special classes, so many courses on Unacademy. That's why I suggest you to follow me over there. Okay. Now, these are the batches which are about to launch. Okay, some of the batches have already started, like 1st of September, 8th, 15th, 15th. You can check. Okay, there are so many batches in which top educators are teaching you. You can definitely check this out. Now, the main point is you can take this plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. Okay, the price for 12 months is this one, 18 months is this one, 24 months is this one. Now, if you want the maximum possible price, maximum possible discount, so you have to use this code. If you are using this code, you can definitely get the maximum possible discount. And there are EMI options available as well. Good evening. There are EMI options available as well. You can basically pay it every single month. And this iconic subscription, you can take it for 12 months, 18 months, 24 months. Okay, by using my code, you can definitely get the maximum possible discount for this one also, iconic one also. Okay, now if you are aiming for JEE 2022 or decided to take a drop, there is something big that is coming up for you. Let that be a surprise for now. You'll get to know everything about this after some time. Now, one of the most important features on Unacademy is basically this ask a doubt, okay? This is one of the beautiful features. If you have unlimited number of doubts, okay? If you wanna basically ask doubt any damn time, okay? So you can basically do that, because this is the feature for that only. Understand? Unlimited doubts if you have, you can ask. A doubt you can ask any damn time, and you will get the videos, that too, video solutions, that too in the high quality. Understand? Our educators are waiting for your doubts every single day so that they can solve your doubts and give you the exact solution of every single doubt. Understand? So you have to basically check. These are basically the features in that one. Now, how can you exactly ask a doubt if you take, see, this is for the plus subscription. If you take the plus subscription, then only you will get this one. Now, first of all, you have to basically go in this doubt session, this one. Afterwards, you have to basically do one thing. You have to take the picture or select from that particular doubt from the gallery. Okay, that should be very clear. The image should be very clear, because our educators should be basically able to see that properly. Then only they would be able to give you the solution. Afterwards, you have to crop that particular doubt. Understand? And the next step is basically, you have to basically choose on which subject that is exactly. These are the details given you over here. You have to go accordingly. Understand? So this is do's and don'ts in Ask a Doubt session. You can definitely read it out, get the exact information from this one. Now, ladies and gentlemen, boys and girls, let's get into the lecture. Let's talk about this today's lecture. What is that? That is nothing but this potential energy, electric potential energy, electrostatic potential energy, electrostatic potential, whatever it is, we're gonna be talking about this entirely detailed. And this is a one shot, okay? In this one shot, we'll be covering. So people have basically made different number of videos on this one. We'll try to cover all of those concepts in just one shot with some of the beautiful problems that you will definitely love about, okay? Everybody is excited. Come on, in the live chat, I just need to know if you people are feeling great. Then I will start accordingly. Fine. Okay. Now, let's have a look. Let's have a look on this one. Listen to me very carefully. What I'm going to be basically, because this was the concept, okay? This was the concept which was messing with my mind when I was preparing for JEE. That's why I'm saying that you people need to basically listen to me very carefully, whatever I say to you, okay? Afterwards, then only you would be able to solve the problems from this portion, okay? Now, let's see. If I say, for example, this is a ground, I'm lifting this block from the ground, okay? There is a ground, okay? I'm lifting this block from the ground. You'll say it has gained some potential energy. This you might have studied in your 9th class, okay? That's fine. We'll go according to that only. So you will say it has gained some potential energy when it is at some height. Understand, at this h height, it has gained some height. It has gained some potential energy. So if you release it, it will fall down. That will be converted to some kinetic, whatever you were saying in the previous case. So ultimately, when you lift this block, at this point, you would say basically it has gained some potential energy. Where does this potential energy come from? So basically, you did some sort of work. You lifted this block at this. So that work is basically converted to what? That work is basically stored as its potential energy. For a second, you just think it like that, okay? So basically, what you are exactly doing, this is Earth, okay? You are lifting this block from this Earth. So basically, this Earth is attracting this block towards itself. So you are doing the work against the gravity. Understand? So you are lifting this block, means gravity is in downward direction. So you are lifting this block in the upward direction. Understand? Applying the external force. So basically you are doing some sort of work. So that work, where will that work exactly go? That work will be stored as potential energy over here. So simply you were saying that this is the potential energy between these two masses, gravitational potential energy. Previously you called this in very simple language, okay? Now, the point over here is, if I say, for example, you replace, okay, let me just give you one more example. If I say, for example, this is a spring system over here. This is a spring and a block is basically attached to this one. Fine. Now, what exactly you are doing? You are applying some sort of force on this block in the inward direction. Understand? You are compressing this spring, okay? What is happening afterwards? This is becoming something like this. Understand? The block is basically being pushed in the inward direction. So can I say in that case, see, this spring force is basically in the outward direction. Spring basically applies the force on us that you go away, don't apply the force on me. Understand? So that spring force is in outward direction. So we are applying the force in inward direction. Understand? Opposite to this spring force. So if I say at this point, it has gained some energy. Understand? So our work has basically what? That has been converted into its potential energy. It has stored some potential energy over here. So we say this is nothing but spring potential energy. For instance, you say over here gravitational potential energy, over here this is spring potential energy. You are doing some sort of work, understand, against that spring force. So that work is basically stored as what? Spring potential energy. Over here you will say at this point, if you release this, it will come back because of that energy. You can understand it like that way also. So now the point over here is, let's come into the electrostatics. This was the case previously. Let's come into the electrostatics. If I say, for example, there is a charge plus q, there is a charge minus q. Now they are attracting each other. This charge is attracting this minus q towards itself. Fine. Now what exactly I'm doing? I'm taking this plus q charge and I'm taking it away from that minus q charge, away from that plus q charge. Okay, so means I am doing some sort of work over here, and work against what? See, basically this is attracting this towards itself with electrostatic force. So I am applying some external force in this case. Understand? When I basically place it over here, now if I release, it will go attracted, it will be attracted towards that. So can I say according, using the same logic, this was the mass 1, this was the mass 2, we basically separated these two masses, this has gained the gravitational potential energy. Can I say basically in this case, when I am separating this charge from this one, it is attracting towards itself. So my work, that work I am exactly using over here, the force I am exactly applying on this one, external force, opposite to this electrostatic force, this work is basically stored as potential energy over here. 100%. If you release this, it will be attracted towards that only. Na? So my work over here in this case will be stored as what? Potential energy. So when you are basically taking this charge from this point to this point, understand? So you are doing the work against this one. So can I say, you said this is gravitational potential energy, you said this is spring potential energy. Can I say this is nothing but electrostatic potential energy? For an instance, you can basically okay, thank you. So basically this is what we call the electrostatic potential energy. Can we say it like that over here? 100%. This is nothing but electrostatic. You call this gravitational potential, spring potential energy. So what is wrong in saying this as electrostatic potential energy? So basically you are doing some sort of work over here. That work by your external force, you are an external agent right now, working against this electrostatic force, taking this from this one. So when you basically release this one over here, this block will be attracted towards ground. So if you release this, it will be attracted. Understand? So you say it has gained some potential energy. If you release this one, it will be attracted over here. Means over here, this is what we call the electrostatic potential energy. I hope you got the feel of this concept. Okay. Now, this was not in that depth. This was not according to that physics. Okay. Let's basically talk about this potential energy in a very depth. From the physics point of view, what is the actual definition of this gravitational potential energy? I hope till here you got the feel of this one. Now let's talk about this gravitational potential energy exactly in physics, how we define it in electrostatics or gravitation. Okay, listen to me very carefully. Okay, am I going fast? I just need to know in the live chat. Then I'll decrease my speed. If I'm going fast, I just need to know in the live chat. Come on. Fine. Now see, if I say this is a mass, this is a Q1 charge, fine over here. Okay, forget about this diagram. I'll just create the another one. Okay. Okay, let's take this one only. Yeah, one second. I'll just make my own diagram. One second. I'll just take this. I'll just place it over here. And yes, I just want to use mine only. Okay, fine. Now listen to me what I'm gonna basically explain you over here. Okay, that's great. Now see what I'm saying. See, if I say, for example, there is this charge over here. This is a charge Q placed over here. This is a point A, okay? There is this charge A. Listen to me very carefully what exactly this potential energy is according to the physics. Now, there is this another charge. I would say this is, I call this as Q1. There is this charge, this is Q2. So, this charge is basically at infinity. Understand, very far from this charge. Now, what I am exactly doing, I'm taking this charge from infinity. So when I'm taking this charge from infinity nearer to this charge towards this charge. So I'll take this charge from infinity. I'm an external agent, whatever, by means of any machine, whatever that is, okay? So I'm taking this from infinity. While taking it towards this one, for example, I reach some point over here, fine. So can you tell me over here, if I say this is the charge Q1, if I say, for example, this is a charge Q2, I'm taking this charge Q2 from infinity. You tell me one thing. This charge will be applying the force on this charge in the outward direction. That's what we call the electrostatic force. Can I say this is nothing but electrostatic force in the outward direction? 100%. Now, what we are supposed to exactly do? We are supposed to basically apply the force against this electrostatic charge, electrostatic force, in order to bring this charge Q2 from nearer to this one only, because if this is positive, so they are repelling each other. So on this charge, electrostatic force will be in outward direction. So if we are supposed to bring this charge nearer to this Q2, this Q1, so what we are supposed to do, we need to basically use the we need to basically apply the force in the opposite direction of this one. So can I call that force as F external force that we are using on this charge? Okay, I'm the person over here, I'm using on this one 100%. Now, see, listen to me very carefully. Listen to me very carefully. So basically over here, when you are bringing this charge from this point to this point, nearer to this point, so means you are doing some sort of work, external work. So which you are doing it. Understand? Your energy is being used over here. You are bringing this charge nearer to this one. So where will this work exactly go? So basically your work is what? Force multiplied by the displacement. So when you are displacing this charge, understand? So force on applying the external force means there is work. Work is being done over there. So can you tell me where will this work exactly go? So this work will be exactly stored over here as a potential energy, like I told you in the previous case. Understand? So this work will be exactly stored as a potential energy. Okay, that's fine. If this work is exactly stored over here as a potential energy, can you tell me how much will be the potential energy at this point exactly? So we got to know how potential energy is being generated over here. Okay, fine. You're bringing this from infinity to this point. So from that, we got to know at this point, how much will be the potential energy. That is, your work has been transformed into the potential energy. Now the point over here is you have to bring this charge very slowly from this point to this point. Okay. Why is it like that? See, if you basically accelerate this charge, or if you bring it this charge with some greater speed, in that case it will have some kinetic energy, means your work, your energy is being transformed into kinetic energy also. We don't want the expression for kinetic energy over here. We are supposed to find the expression for potential energy only. Understand? Oh, okay. Oh, this is lagging. Yes. I told you there is the internet issue in Kashmir. It's because of that only, maybe. 1 second. I just need to check it, man. One second, guys. Yeah, it's because of that only. I told you in the beginning itself, I'm not lying. That's why I was at that kind of break from past few days. It's because of that only. There is some disturbance actually in Kashmir right now going on. Some sort of disturbance in the whole valley. So because of that, it is like that Delhi scene, okay? Yeah. Okay. I was having a hell lot of energy today. I wanted to basically clear this concept. Okay. Is it fine now? Is it fine now? Yeah. Or is it lagging once again? Yeah. Okay. Let's just go. I guess this is fine now. Okay. I guess everything is okay now. Yeah, yeah. Okay. Let's go with this. Okay. See, so what I'm exactly is doing that. So this external work done is basically stored as potential energy over here. Now I'm saying you how much amount of potential energy is being stored over there, or how much amount of potential energy is exactly at that point. So how can you exactly find that? Let me just tell you how can you exactly find that. Okay. So basically that work done, external work done is being converted into that potential energy. Understand? So that's why we say we'll find exactly the work done exactly over here. So you just try to find out this work done. So this work done will be exactly stored as potential energy. So whatever the work done will come over here, that will be stored as potential energy. Yeah, that will be stored as potential energy. So we can definitely say it like that. Okay, this is the point number one. Now, I told you the second point that you are supposed to bring this charge very slowly. Why? Because you don't have to transform your energy into kinetic energy. Kinetic energy should be zero while bringing this charge from infinity to this point. So you are supposed to measure the potential energy at this point only. So for that, your energy, whatever the efforts you are using, it should be completely transformed into potential energy. Then only you will get the exact value of potential energy. Okay? Is it fine or is it lagging once again? Can you tell me in the live chat? Is it fine or is it lagging? Guys. Okay, okay. Okay, then let's go. Fine. So what I exactly did? Brought this one. Let's find the work done exactly over here. How can we exactly find the work done? See, if I say, for example, at this point, this is at, for example, when we were bringing at some point, the distance was, it was at X distance from this one. Okay, fine. Now, when we basically took it, we displaced it a bit, dx, understand, of a dx. I'll just show you over here. We displaced it a bit. Once again, that is a dx. So using, you are basically applying this external force, Now, can you tell me how much is the work done over here? It is very simple now. Work done, how much? That is f dx cos of theta. Understand? Cos of 180. Understand? In this case. So you tell me one thing. Can I just write this as f external in this case into dx and cos of theta 100%? Now you tell me one thing. I told you, see, in this case, you are supposed to bring this charge from infinity to this point very slowly. Means that you are supposed to apply what? Little, exactly this amount of force. If, for example, this is the electrostatic force over here, you are supposed to apply this external force that should be exactly equal to this electrostatic force. Then only you can bring this charge from this point to this point very slowly. Understand? Otherwise, otherwise it will accelerate. See, If you say, for example, this external force, you will apply more external force as compared to this electrostatic force. So in that case, net force will be something. So when there is net force, there is acceleration. If the particle will accelerate, we say there is kinetic energy. So there shouldn't be any sort of kinetic energy. Entire energy should be changed to potential. So that's why I'm saying this should be exactly slightly. You'll say, sir, if this is exactly equal to this one, they'll cancel each other. How will this move forward? Say slightly more than that. Negligible, understand? So then only we'll get the exact expression for potential energy, ladies and gentlemen. Then only we'll get the exact expression for potential energy. Okay. Okay, chalo. So can we just write it now? If we want to find this work, then instead of this external force, I can write the electrostatic force, because I know how much amount of electrostatic force is exactly at this point. How much that is? You'll say, sir, that is very simple. We can easily find that because of this force on this force, because of that charge on this charge, how much will be the electrostatic force? That is nothing but K, this Q1, this Q2 upon this. How much is the distance between them? That is x square exactly. Understand? So finally, I would say this charge reached exactly this point. And this distance, this is the, for example, Q2, this is the final distance. So this was the point where we were supposed to brought this charge from infinity. Understand? Point A, point B, this is at r distance. Understand? This is any point we are taking through when we were taking this in its path. Understand? Now, can you, this is KQ1, this is the extra, this electrostatic force. So can I just write multiplied by this dx exactly, multiplied by this dx exactly, and cos of, what is the angle between electrostatic force and displacement? Displacement is in this direction. Electrostatic force is in this direction, 180 degrees. So cos 180, that is -1. I can write it like that. You can go with like that also, okay? Even if you do not put this negative sign, still the answer is going to be the same, okay? Now, so can we just write it, take it over here? So it will be nothing but kq dx, k q1 q2 by x square, this dx exactly, and this is negative. Now, if you want to find, this is the little work done. If you want to find the total work done from this point to this point exactly, understand? If you want to find the total work done in bringing this charge from infinity to this point, you will say what? From infinity to r, what you will do? You'll integrate this one in order to find the total work done. So integrate this one from where to where? From infinity to r exactly. From infinity to r exactly, you'll get the total work done. That is nothing but negative of this k q1, this q2 upon this x square, and this will be nothing but a dx. Understand? Everybody understood till here? Everybody understood till here? Let me just add the slide. Okay. Yo. Okay. Fine. So what we exactly got over here, that is this one, k q1 q2 by x square from infinity to r. So can we just write it? This is from infinity to this r, that is k q1, this q2 by r square. This is x square exactly. Why this is x square? This is x square because this is at x distance, and this will be dx exactly over here. So it will be nothing but, can we just write this is minus? So further we can definitely write it, this k q1 q2 both are constants, take this out, so we can definitely write it, this k, this q1, this q2, and we'll basically go for the integration from infinity to this r, 1 by x square, and this will be dx exactly. Okay, fine. Is it lagging or everything is fine? Come on, I just need to know in the live chat. So can we just write it? It is nothing but that is my minus of k q1 q2, and integration of this 1 by x square is nothing but 1 by x. Understand? 1 by x square minus of 1 by x from infinity to r exactly. Now if I say how much it will be, you will say, sir, it is nothing but k, this q1, this q2 upon, first you will put what? This minus minus will get cancelled off. So you will first put, that is 1 by this r, then you will put the another limit, that is 1 by infinity. So 1 by infinity, you take it as 0. So this is nothing but k q1 q2 by r exactly. Now you say this is work done. This work done is stored as potential energy. So can I directly write this is equal to this u? So this is the expression for potential energy, that k q1 q2 by r. So at this point, how much potential energy has exactly stored? That is nothing but k q1 q2 by r. Guys, is it lagging or is it fine? I just need to know. Okay.
Guys, is it fine or is it lagging? Come on, I just need to know in the live chat. Okay. If it is fine, then it's great. Let's move further. Fine. Okay. So we got the expression for this potential energy, means at this point exactly potential energy will be how much, that I told you that we got this expression exactly. So how much, that is K Q1 Q2 by R square, this R exactly. Fine. So this is the general expression. Now if you want to find the potential energy, you can find with this one. And remember one thing, this potential energy is always between the two charges. Understand, between it is between a pair of charges. Understand? So why is it between the pair of charges? See, it is very simple. So we are bringing this charge. What is the definition of potential energy? The amount of work done in bringing this charge from infinity to that point. So that is nothing but stored as potential energy. See, if there was no charge over here, you are bringing this charge from infinity. That means you are supposed to do no work done. There is no work done from your side. So you are applying no force. Understand why? See, because this is applying the force, electrostatic force in the outward direction. So you are opposing that. So you are doing the work against that electrostatic force. If there was no electrostatic force, if there is no charge, only one charge, you are supposed to find the potential energy at this point. So you will basically push this point from infinity. So it will keep on moving. So no force required, no external force required. So no work done will be here. No potential energy will be here. Because potential energy is the amount of work that you do it in bringing this charge from infinity to that point. That's why I am saying, okay, fine. Let's move basically further. Let's talk about this one now. Let me just give you the feel of this one now. See, now, if the two charges are positive and negative, now in this case, I'm asking you to tell me the potential energy between these two. Previously we got, that is U Q1 Q2 by R. Can you find it over here? For example, this is negative charge. It's very simple. That is U is equal, that is K Q1 and this minus Q2 by R. Exactly. Very simple. Just put the negative sign over here. Understand? In that case, potential energy came out to be the positive. Over here, this negative sign represents that one of the charges is exactly negative. So you will say this is K, this Q1, this Q2 by R exactly. Now, if both the charges are negative, in that case, how can you find the potential energy? You will say simply that is nothing but this K of this minus Q1, this minus Q2 upon this R. So can I just write K is equal to this K and this is Q1, Q2 by R exactly. I told you, you just have to remember that one single formula in the first. Afterwards, you can finish, kill every damn question from that itself. Understand? Now, there is this beautiful concept that people say change in potential energy is defined in physics. Understand? Not only potential energy is defined in physics, but change in potential energy is defined in physics exactly. Let me just tell you what is this change in potential energy exactly over here. Listen to me very carefully. Okay? People say this is exactly defined in physics. Not only the potential energy, you cannot define the potential energy individually, but you can define the change in potential energy. Let me just give you the feel. Understand? See, if I say, for example, what was the formula for potential energy? Okay, that you got over here. So this one, understand, in bringing the charge from infinity to that point, understand? So can I just take this exactly over there? This from here, I'll take it. Okay, so that is nothing but this minus of this K Q1 Q2 by R x square into this dx from infinity to basically R. Okay, you are basically trying to find out the expression for potential energy. Let me just give you the feel. So can I just write, it will be exactly equal to, this is nothing but minus of this, how much? This K, this Q1, this Q2 will come out and it will be integration of this 1 by x square dx. So it will be nothing but 1 by x from infinity to r exactly. Fine. So you know this is potential energy, you know this is potential energy. This work done, this is work done exactly. Total work done from in bringing the charge from infinity to that point. This will be stored as potential energy. Now see, can I just write exactly over here? This is nothing but this will be K, this Q1, this Q2, and first you put the upper limit. So this will be minus 1 by r exactly. Then 1 by this infinity exactly. Can you tell me it will be nothing but this K Q1 Q2 by r minus this K Q1 Q2 by this infinity. Now see, what is this K Q1 Q2 by r? This K Q1 Q2 by r was the potential energy at that point between those two charges. Fine. You tell me one thing, what is this K Q1 Q2 by infinity? So this is the potential energy at infinity according to the same logic. So can I say this is nothing but potential energy at that point? For example, if I'm bringing from point infinity to that point A, so minus potential energy at infinity exactly. Can I say it like that? You tell me one thing. See, what is this? This is change in potential energy from infinity to that point. Because after on finding the work done, what we are exactly getting? This one. Previously, I was neglecting this 0. So then I directly got U is equal to this one. Now, when I basically completely did it, when I put the limits exactly, and what I exactly got, this one. So in this case, what I am exactly getting is nothing but change in potential energy. That's why we say this is defined in physics. Now we say potential energy at infinity is basically 0. So if that is the case, so this becomes 0. So this becomes 0 potential energy at infinity. So what you will get, that is UA is nothing but that is K, this Q1, this Q2 by R. Understand? So this is potential energy at a point. Now, if I say what is defined in physics, that is this one. Understand? This is completely correct. So this, where does this come from? This only. When you are taking this another potential energy at this point B as 0. Everybody understood this one? I hope so. Let's go further. Next, let's go for this question. Now, can you solve this question? We say potential energy for a system of particles. Understand? If there are different types, number of particles. Understand? 2 or more charges. Understand? 2 or more charges for different number of charges. 2 or more charges. In that case, how can we exactly find the potential energy, which is very simple? Okay, we say potential energy is basically between the pair of charges. Okay, it is basically between the pair of charges. So how many charges are over here? So this is the first pair, this is the second pair, and this is the third pair. So can I say between these two, and between these two, there will be the potential energy? That's for sure. So how much will be the potential energy? You will say, sir, potential energy net in this case will be potential energy between these two. I told you, it is created basically how? Between these two. When we basically take this charge from infinity to this point, so then only that work done will be stored as potential energy. When this was replying this, when this was creating the electrostatic force on this one, then only that is stored as this one. Okay? Now see, what I'm saying exactly over here, how much will be the potential energy? You will say, sir, that is nothing but K, this Q1, this Q2. What is the distance between these two? That is R2. Fine. Now, find the potential difference between potential energy between these two. You will say that is nothing but K, this Q2, this Q3 upon this R1 plus between these two, that is this Q1, Q3 upon this distance, that is K, Q1, Q3 upon this distance, that is R3. Understand? You just try simply add all of these potential energies, you will get the total potential energy. Fine. Let's move on to the next one. Okay. Listen to me very carefully. This is a very good question. This is having a very nice level. You can definitely solve it by yourself if you can. So I want you people to tell me the answer of this question before I do it exactly. Okay. So this is the point over here. Okay, sorry. This is exactly the charge over here. This is exactly charge over here. It is saying that this plus Q charge is placed at this point. This plus Q charge is placed at this point. Such that the difference between these two is what? This is what? 6 meters. Understand? 6 meters. And this is the perpendicular bisector. So there is another charge exactly at this point which starts from rest. This is a negative charge. Okay, negative Q. Equal and opposite charge started from moving from C to D. There is this another charge which started from this point towards this point. So it is saying that this distance from this to this, it is given as 4 meters exactly. Now, what they are asked in this case is, we are supposed to find this distance. Understand? We are supposed to find this distance. So when it starts traveling from this point to this point, it will come back. So we are supposed to find this distance. This is the information given. This charge, this charge, this charge is given over here. This starts traveling towards this one. Now, one more point is that it says that when this charge travels from this point to this point, it loses 4 joules of its kinetic energy. This is also given. So can we solve this question over here? Can we solve this question over here? Now see, we'll try to solve this question with the conservation of mechanical energy, okay? Total initial energy is equal to total final energy. Can I say that total initial energy, that is Ki plus total kinetic energy initially plus potential energy initially is equal to kinetic energy finally plus potential energy finally, okay? Now you tell me one thing, if we take it over there, so Ki minus Kf is nothing but this will be Uf minus Ui. So in the question itself, this is saying that when this charge travels from towards the right, it is losing 4 joules of the kinetic energy. Means what was its initial kinetic energy minus final kinetic energy? Finally is how much? So means initial minus final. So that is loss. Loss is how much? That is given 4 only. So can I just write 4 from this side? Exactly. So it will be equal to this Uf minus Ui exactly. Now you are supposed to find this final potential energy, means when the charge is exactly at this point, because this is the final position of this charge. Initial potential energy when this charge is exactly at this point. Understand? Now how can we find that? How can we find that? Let's try to find this let's find the final potential energy first. Let me show you. I hope everybody is able to understand this one. Come on. Now tell me over here, we are supposed to find this one, okay? Not that one. 4 joules distance we are supposed to find. So what is the final potential energy? Means when this charge is exactly at this point. What has happened to this one? Okay, for example, this charge is exactly at this point, okay? Now see, I'm saying that if this is 3 meters, this is x meters, how much is this distance exactly? From this point to this point, you'll say, sir, it is very simple. That is nothing but x square plus 3 square, that is 9. Okay, that is 9. Okay, now you tell me one thing. If I ask you to tell me the final potential energy, you will say, sir, when this charge reach this point, so means final potential energy will be potential energy due to this pair, potential energy due to this pair, and potential energy due to this pair itself. Understand? So can we first find the potential energy due to this pair? That is very simple. How much is that? That is nothing but this is K, this Q, that is Q square, upon, both are having the same magnitude, upon 3 plus 3, distance between them, that is 6. Okay, fine. Now can you tell me the potential difference between potential energy between this pair? Understand? You will simply say that is nothing but plus, that is plus Q, because this is minus, plus when this reaches over here, this is minus, that is eventually I'll write this is nothing but K, this Q, this minus Q, upon this root of x square plus this 9 plus. Now potential energy between this one and this one, you will simply say that is nothing but K, this Q and this minus Q, again upon this root of x square plus 9 exactly. Fine. Now see, this is twice. I can definitely write it. UF is nothing but this is K Q square by 6 plus, and instead of plus I'll just write minus, because this is having the minus charge over here. This is having the minus charge over here, so I can definitely write this is minus twice K Q square upon a root of x square plus 9. Okay, so we got the final potential energy, means final potential energy of this one, final potential energy of this one. Now afterwards, what we are supposed to find exactly in this one? So we got this final potential energy. We got this final potential energy. I'll tell you everything. Okay? No, this is live class. This is not the premiere, okay? So we got the final potential energy. Can you tell me initial potential energy? It is very simple now. Initially, when the charge was exactly at this point, so potential energy of this pair, and of this pair, it is very simple. Between this pair, it will be exactly what? That is K Q square by 6 exactly, and then because of that, it will be nothing but 2K Q square minus 2K Q square upon the root of how much? That is 4 square. This distance is how much? This distance is how much? This will be 4 square. Root of 4 square plus 3 square, that is root 25. That will be 5. Root 25, it will be eventually 5. So ui is nothing but that is k q square by 6 minus 2k q square by 5 exactly. I hope everybody is able to understand this one. Now listen to me very carefully. Listen to me very carefully. So now put it over here. Final potential energy in this one. 4 is equal to final potential energy. That is nothing but k q square by 6. And this will be minus 2k q square upon minus 2k q square upon this root of x square plus 9. And then minus initial potential energy. It will be nothing but how much? K q square by 6 minus this 2k q square by 5 exactly. Fine. So further, if we simplify this, it will be nothing but take this kq square common in all of these. So it will be kq square exactly. So it will be 1 by 6 over here minus 2 by a root of x square plus 9. And this will be minus, if you multiply this over here, this will be exactly 1 by 6. Okay. Yeah. And this will be plus 2 by 5 exactly, because we took this as a common. So this and this will cancel. So 4 is equal to, so it will basically become, that is, take this 2 also common, that is 2k q square, and over here it will remain 2 by 5 minus 2 by a root of x square plus 9 exactly. Okay. Now you need to put the values and you will get the value of this one, because everything you know. So can we just write 4 is equal to 2? What is the value of k? 9 into 10 raised power 9. And this q square, that is given. How much is the charge given exactly over here? 5 into 10 raised power minus 5 into 10 raised power minus 5. It is square exactly. And multiplied by this 2 by 5. This 2 by 5 minus 2 upon root of this x square plus 9. Okay. Once you simplify this, you will get this x exactly, because everything is given over there. You are supposed to find this x. It will be nothing but root 72, I guess, something like this. So it will be nothing but 8.48 meters. Fine. This is what we are supposed to find in this. Let's go for the next question. Yeah, can you tell me the answer of this question? Okay, that's great if that is clear to you. Can you tell me the answer of this question? Now see, potential energy, find the U of the system. Potential energy is always between the pair. So first between this pair, plus between this pair, plus between this pair, okay? Plus between this pair. Now tell me, how much will be the potential energy exactly over here? So you'll definitely say between this pair, it is nothing but U is nothing but that is this K, this Q, that is Q square upon, what is the distance between these two? That is A. Plus between these two, K, Q upon A, that is K Q square upon A. Between this pair also plus K Q square upon A. Can we just write is that is nothing thrice K Q square upon A. Next question. Can you solve this question? Okay. See, what is this question saying? That there is this charge plus Q2, Q1 placed over here. All the three are positive charges. So this started from rest. This charge started from rest. It falls in this direction. It moves in this direction. It is saying that when it is exactly at this point, what is it? How much is its speed? Okay, it started from rest. Use that total kinetic energy. Kinetic energy initial plus potential energy initial is equal kinetic energy final plus potential energy final. You'll get the answer. So what is the kinetic energy initially? That is 0. Okay, plus why is 0? Because this is starting from rest only. These two are also at rest. Fine. So what is the potential energy initially? You'll say potential energy is initially because of these two. and because of these two. How much that is? Can you calculate that? Between these two, you'll simply say that is K, this Q1, Q2 upon distance between these two, that is 6. Plus, between these two, how much that is? See, this is 4, this is 3. This is how much? This will be root of 4 square plus 3 square. That is nothing but root 25. That is 5. So this will be K, this Q3, this Q2 upon this 5 plus. And between this and this, it is nothing but that is K, Q1, Q3 by that 5 only. It will be equal to kinetic energy final 1 by 2 mv square plus, because when it was exactly over here, we need to find the speed. So finally it is having some speed, it will have some kinetic energy. Now you need to tell me what is the potential energy finally. You'll say because of when the charge is exactly at this point, okay, this is Q3 now. So because of these two, that is simply K Q1 Q2 by 6. Now because of these two, it will be plus K Q3 Q2 by 3 only, because distance between these two is 3 only. Now because of this and this, you'll say that is plus K Q1 Q3 by 3 only. Now in this case, you put the values and you'll get the value of this V. Let's move on to, okay, there is another question. We need to solve this one as well. Everybody understood this? Okay. Now can you solve this question? This is a charge over here. 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 Okay. These are the charges placed over here. You will say, sir, there is a potential energy between pairs. Okay. So the first set of pair will be this one. Okay. If I say keep this as negative, then it will be having good level. So between this pair, sir, between this pair, understand? These are the pairs that I can create over here. And sir, then it will be between this pair and then it will be between this pair. Now try to solve this one. Tell me how much is the potential energy. You will simply say, sir, the potential energy over here is between this pair and this pair, positive and negative. That is K Q1 Q2 minus Q2. So that is minus K Q square by R. Okay, first between this and this, because one charge is positive, one is negative, that's why minus. Now between this and this, it will be, sir, plus K Q square by, if I say this is R, so this is R. Sides are basically R. Okay, so this is R, plus, sir, between this and this, it is nothing but a minus. Once again minus. Okay, once again this is a minus, so that is this minus K Q square by R. Sir, between this and this, it will be plus, because this is minus, so both will be plus K Q square by R. Understand? Then afterwards, can I just write between this and this how much? If this is R, can I say this is R root 2? So that is K Q square, Q, that is Q square, and what is the distance between these two? That is R root 2 whole square. That is 2R square. Can I just write it like that? And it should be negative only, because one charge is, this is negative, this is positive. Okay, it shouldn't be plus exactly. And then the another one will be also same, that is minus K Q square by 2R square. So this will cancel, this will cancel. So finally I would get this U will be twice K minus 2K Q square by 2R square. This will cancel. Check if it is correct. Q square by R. This is not, hey, it shouldn't be, yeah, it's R square exactly. Fine. 2R. Oh, it shouldn't be R square exactly. Yes. It is. It should be root 2 over here. Okay, it should be root 2 over here. I'm not calculating the force. Okay, R root 2. It should be R root 2. 1 second. It should be basically this R root 2. This is R root 2. Okay, R root 2. So eventually what we'll get exactly over here, let me just show you this once again. Okay, fine. So it will be nothing but, that is nothing but twice minus 2K Q square by R root 2 exactly. Let's move on to the next one. Fine. Yeah, what's up? Okay. what is potential now? Okay, this is a very good concept. Okay, like when I was in my when I was preparing for JEE, that point of time, this was the concept which was messing with my mind. Okay, I was feeling this is one of the difficult, I was feeling this was the only difficult concept in physics, because taking the feel of this concept is a bit difficult. Okay, that's why it may create the problem in you as well, but I won't let that happen. Let me just show you. Electric potential, I'll just write it over here. Electric potential, exactly. Wait, how I will exactly make you understand this one. See, if I say, for example, there is a charge over here. Okay, there is a charge over here, and there is another charge. I would say this is Q naught, unit test charge, Q naught, 1 coulomb of charge at infinity. Fine. So I'm bringing this charge very slowly, very slowly. This is applying the force on this one in the outward direction, because this is repelling this charge. Okay, this positive, this unit test charge is also positive. So we are doing some work in bringing this charge nearer to this charge. Understand? So we are bringing some work in nearer to this charge. For example, we placed it over here. Okay, this Q naught, we placed it over here. Now you will say, sir, this work is completely changed. This work is completely stored as potential energy, because we are doing work. That work should be stored in some sort of energy that is stored as potential energy. Why not kinetic energy? Because we are bringing this very slowly. I have told you this before. We are bringing this very slowly so that our energy shouldn't convert into the potential kinetic energy. Our energy should be converted to potential energy only. I'm saying, okay, we brought this charge from this point to this point. That's okay. Now, if I ask you how much is the potential energy at this point, you'll say, sir, at this point, potential energy would have gained at U. Why? Because that work is converted to potential energy. Now, how much that will be? I would say that is U. If I ask you, divide this U by this Q naught. So this is some quantity. What is this? Potential energy per unit charge. Potential energy per unit charge. Listen to me very carefully. If I say, for example, this is a charge. At this point, exactly at this point, if I say potential energy is U, potential energy per unit charge is some quantity. If I ask you how much is exactly at this point electric field, you will say electric field at this point is nothing but force per unit charge, F by Q, this Q naught. Understand? F by Q, F by this Q naught. Understand? Can I say it like that? Force per unit charge. So this force per unit charge, you are saying that this is nothing but electric field. So this potential energy per unit charge at this point, what name you should give it? See, you are giving this name as electric field. So what name you should give to this quantity? You give this name as that is nothing but potential. We represent this potential with V. Okay? Listen to me very carefully. I hope you are able to understand this. So what is this potential now at this point? Potential is nothing but potential energy per unit charge. Like this is force per unit charge. How much we get this? This is K Q1, this Q naught upon R square. Understand? Then this Q naught will cancel. So eventually what you will get over here, that is K Q by R square. Fine. So how much will be the potential exactly at this point? You will say, sir, it is very simple. So this is nothing but that how much is basically this Q, U, that is, you will say, sir, this is Q, K, Q, this Q naught upon this R, and this Q naught as it is this will cancel. So this is nothing but K, Q by R. So what is this? V is equal to K, Q by R is potential at this point. Understand? So what is this exactly? I'll make you. There are so many confusions going on in your mind right now. Sir, what exactly this? We are not getting the feel. Hold on for a second. So this electric field at this point is that is nothing but K, Q by R square. You'll say, sir, this electric field at this point is K, Q by R square. This is. So both are the functions of what? Position. Now, if I try to explain this potential from the other point of view, see how I can exactly explain this to you. At this point, if you want to define the electric field at any point, how can you define it? Either you define it with this electric field intensity or electric field strength, K, Q by R square, because this is the formula for electric field, or you can define it with this also, this potential also. See, there is only difference of this R. I'll tell you how you can exactly define with this one. I'll tell you. I'll give you the feel of that. Okay, let me just show you over here. Let me just show you over here. Listen to me very carefully. If I say this potential at this point is V is equal to K, Q by R exactly. Fine. Now, if I ask you to differentiate this one with respect to R, you will say, sir, this is nothing but dV by dR exactly. So can I just write kq? Both constants take it out. So 1 by r dr. Understand, you are basically differentiating this one with respect to r. So it will be nothing but kq 1 by r, differentiation of 1 by r, that is minus 1 by r square. So it is nothing but kq by r square, exactly. So what is this kq by r? Kq by r square, that is electric field. So dv by dr is nothing but electric field. This electric field, I can write it negative. So what we exactly got? Minus dv by dr. That's what I was saying. If you want to define the electric field at a point, how can you define it? See, electric field, you take the potential at that point, you differentiate it, you will get the electric field. If you want to find the electric field at this point, you can either find it by this formula, or if you know the potential at that point, you can find it this formula. That's why potential is something that is defining the electric field at that point. Understand, at any point. Like this one. This is the one definition of potential. Okay. The other definition I'll make you understand, that is, I'll show you. So this was the first, this was first. Second, what is first? Potential energy per unit charge. At this point, how much is potential energy per unit charge? Potential energy per unit charge. Second one is this. Now, let me just tell you the another definition, third definition. If I say, for example, this is a charge Q. At this point, how much is potential? You will say potential energy. You will say, sir, that is nothing but K. If I say this is Q naught over here, K, this Q naught upon this R. Fine. Now, if I ask you to increase this Q, you make it Q 2Q. So you make it 2Q naught. So how much will be the potential? New potential energy, you will say KQ 2Q naught by R. So on changing this value Q naught, this potential energy changes. Now, if I ask you to tell me the potential at this point, you will say that is nothing but KQ by R. Now, if we increase this Q naught, will it affect this V? No, because there is no Q naught in this formula. Here it was. Instead of Q naught, we need to put 2Q naught. So potential energy varies, potential energy changes. Now, at this point, there is some quantity which remains constant. That constant quantity is nothing but potential. You can understand it by this way also. Understand, what is this potential? What exactly? This is potential energy per unit charge. See, at this point, if I ask you how much is the potential energy, this much. So potential energy changes, but there is something which remains constant. If even you change this Q naught, still it remains constant. That effect, that quantity is what we call the potential. Or you can understand it by this. At this point, what this potential is nothing but potential energy per unit charge. So it will remain constant. For this Q naught charge, it will be potential, how much potential energy is exactly at this point. Understand? Or you can understand it like this one. At any point, if you are supposed to find the electric field, if you know the potential, differentiate that, you will get this one. Or the fourth definition is, that is very common definition. Potential is nothing but bringing a charge, test charge Q naught from infinity to some point. Understand? From infinity to some point. For example, point A, divide that. How much will be the potential energy at that point? Divide that by that charge Q naught. That is nothing but potential. Potential energy per unit charge. These are the definitions by which you can understand the potential. I just need to know in the live chat if you understood this potential, if you got the feel of this potential. Come on. No one can give you the more feel than this in case of potential. Come on. Okay, let's move. Now, this potential difference. People say this potential difference is basically defined in physics. Defined in physics, okay? This potential difference is defined in physics, okay? This potential difference is basically defined in physics. People say, not a potential, like change in potential energy is defined in physics, not a potential energy. Same is the case over here. Now, let me just tell you what is potential difference. If I say, for example, this is a point B, over here, what is potential? This is potential VB at this point. At this point, this is a point A. How much is the potential? You'll say VA. How can you calculate this potential at this point? You bring the charge from infinity to this point. How much amount of work is being done, that is stored as potential energy. Divide that by charge Q naught, that is the potential at this point. Okay, simple, very simple. Or potential energy per unit charge at this point is potential at this point. At this point, bring the charge from infinity, that potential energy divided by that charge q naught, that is the potential energy at this point. Okay, fine. Now if I ask you how much is the change in potential between this and this, you take the charge from this point to this point and you say check how much came out to be the change in that case. A simple change in potential, that is VA minus VB. If you are taking this charge q naught from this point to this point, how much is the change in potential in taking this charge from this point to this point? Divide that by, in taking this charge from this point to this point, how much amount of work is being done, that is external work done in taking the charge from B to A upon this charge q naught. Why upon this charge q naught? Because we are defining potential. Potential is nothing but this work done upon this charge, test charge, or potential energy upon this charge. So this is nothing, this is basically defined in physics. This is 100% working, okay? Potential at a point is not defined. So what is potential difference? Basically taking the charge from this point to this point, check how much amount of work is being done, how much potential energy is being stored, divide that by this q naught. So you will get what? Potential difference. You try to get the feel of this one. Potential at this point, potential at this point. If you take this charge from this point to this point, so you are measuring how much potential came out to be the change in potential. Understand? So that is nothing but potential difference in this case. So how can we, from this one, how can we exactly define the potential at a point? Let me just tell you exactly that. Can I just write it as it is VA minus? See, if, for example, we are taking this case, from here we are taking this charge from infinity to some point. So point number B is nothing but infinity. Point number A is nothing but this. So this is B. A, understand? In this case, if we are supposed to define the potential at a point, understand? So in that case, I would write VA minus V infinity, because in that case, second point we take as infinity. Fine. Okay. Now, can you tell me what is the work done in bringing the charge from infinity to that point? Over here it is from B to A, but we are taking the case from infinity to that point. We'll say it is very simple. That is work done, external work done from infinity to that point. So external work done, that is force. As I told you in the beginning itself, that is force. What force? Electrostatic force, okay? You can say basically electrostatic force, because that external force is equal to the electrostatic force already explained previously. So electrostatic force, if electrostatic force multiplied by the distance dx, multiplied by the distance that dx and that cos of theta, okay? As I told you in the beginning itself, okay? Upon this q naught exactly. Upon this q naught exactly. Can I just write it over here? VA minus V infinity is nothing but this. We were basically same derivation we are doing. That is this F electrostatic into this dx upon this cos of theta. Understand? Cos of theta upon this q naught exactly. Can you tell me cos of theta between electrostatic force and this one? It was -1, came out to be -1, or this was the negative work done. Whatever it was, we have done it previously. VA minus V infinity is nothing but how much this electrostatic, that is KQ, this q naught. We are bringing the charge from infinity to that point. Understand? So this is basically, we are supposed to find the potential energy over here. Work done, that is only stored as, the work done is only stored as potential energy. KQ naught upon this r square. Why r square? Because we are talking about the force, okay, between this point, one charge and another charge, and this is nothing but q naught. We are done with this previously in the starting itself. That's why I'm going a bit fast over here. So this is upon this q naught, and this is -1 cos, and you can basically take it over here. Okay, now if you want to find the total work done, go from infinity to that r. So can I just write VA minus V infinity exactly? So take this minus out, it will be nothing but K, Q out, it will be integration of this from infinity to this R, 1 by R square exactly. And this will be dr. Or you can take this as x, okay? This is x because we were taking in the starting over here this as x. Understand? We are bringing this charge from infinity to this point. We are finding this work done. Same derivation we are doing over here, okay? Take this as x. We are displacing it by x, okay? So this as x, so it will be dx over here. So it will be dx, and this is x square. Now, can you just tell me, it will be nothing but a kq of, it will be -1 by x, okay? Kq of, it will be -1 by x, so I'll just write 1 by x minus will get this one. So this will be infinity to this r. So can I just write this is kq into 1 by r minus, put the first limit, upon 1 by infinity exactly. So this is VA minus V infinity. Now this will be nothing but VA minus V infinity is nothing but this is KQ by R minus KQ by infinity. You tell me one thing now. What is this KQ by R? Potential at a point. At what point? Potential at point A. What is this KQ by infinity? Potential at infinity. That's what I was saying. I was neglecting. I was basically putting it 0. I was directly getting KQ by R. So what is the exact definition? This one. So what we got exactly? Change in potential. Potential difference. Understand? Potential difference. VA minus V infinity. Over here, second point is at infinity. So this is potential difference. How much came out to be this? Now we say this potential at infinity we take as 0. So if we take the potential at infinity 0, so this will become 0, this will become 0. So we'll get potential at A, that is KQ by R. So what is exactly defined? This is basically defined in physics. Now from this only we are getting the potential at point. Come on, I just need to know in the live chat if you got the feel. Okay. You understood? You understood this one? Come on. Hey. Abhi. Hey, Abhi. This is this negative sign for this. What is the integration of this one? That's minus 1 by R. Minus and minus you can get cancelled. Don't worry about this negative sign. Understand? Even if you don't mention it, still you will get the same answer. Understand? That's why you got this one. Let's move. Okay. Now we have this question over here. Come on, can you solve this? The electric potential at a point is 20 volts. At point B, it is minus 40 volts. Find the work done by the external force and electrostatic force in moving the electron from B to A. Come on. Same formula we need to use over here and we can solve this question. Now see. Okay. Now see how can we exactly do this. See. Potential at point A and potential at point B is given. We need to find the external, we need to find the work done by external force, okay? So we know potential at point A minus potential at point B is nothing but work done by external force in bringing the charge from B to A divided by that Q naught. See, this one, okay? Now, over here, you take it over here. Can I just write work done by external force is nothing but, it is nothing but, this is Q naught into VA minus VB. This is what we are supposed to find out. Work done, find the work done by the external force. So this is work done by the external force will be nothing but, it is Q naught. How much? This is in moving an electron, that is minus 1.6 into 10 raised power minus 19. It will be minus multiplied by VA is nothing but 20 minus this minus, and VB is nothing but minus 40. So how much it will be? Work done by external force, it will be nothing minus 9.6 into 10 raised power minus 18. Okay, so this came out to be the work done. Now by electrostatic force, we say work done by external force is negative of work done by external force is nothing but negative of work done by electrostatic force. So it will be nothing but negative 9.6 into 10 raised power minus 18. Okay. See, we were basically doing the work done against that electrostatic force. Okay. So this force, external force, was equal to that electrostatic force. Understand? So this work done was equal to that work done. Both this force and this force, they are equal and opposite. Understand? That's why we say it like this. Okay. Everybody like this session as soon as possible because you need to mark the attendance. That's mandatory. Come on. Now, electric potential due to the charged rod. Like we were basically previously discussing, electric field due to a point charge, then electric field due to different number of charges, then electric field due to a charge distribution. If there is a rod, charges distributed on that rod. Same is the case over here. If there is a previously we found what is the electric potential because of that basically we were dealing with the separate charges, discrete charges in that case. Now if there is a rod, because of this rod, how much will be the electric potential at this point exactly, that we need to find out. Okay, this is that same charge distribution. Okay. Thank you. Let's go for this one. How can we exactly do this? See, we know how to find the electric potential because of single charge. Okay, very small one. I will take this as a very small charge. Understand, I will definitely call it, this is nothing but that is dq. Okay, now this is, for example, how much far from this point. I would say this is at x distance. So I'll find basically because of this dq at this point, how much will be the potential at this point. So understand, in this one, how can I exactly find that potential? You need to take the charge from infinity, from this point, and you place it over here. And now I am directly saying that because of this one. Don't get confused, sir. Because of this one, what are you saying? What is your language? So you need to understand this. So at this point, exactly because of this charge, you'll say, sir, bring the charge from infinity to this point. Find out the potential difference, find out the potential energy because of that. Divide that by this charge q naught, this unit charge q naught. Understand? So when we divide this by unit charge q naught, in that case, we'll get the potential at this point because of this one. Either you say because of this one, whatever the language is, this has to basically be that concept. So I'm directly saying that now because of this one at this point. You'll say, how much is that? We know potential is nothing but V is equal to kq by r. Now, at this point, because of this charge q, so it will be dv, understand? So that is nothing but k this dq upon how much is this distance, that is x. Fine. Now you tell me one thing, this is a rod. Charge is basically distributed on this rod, understand? So can I say that in this case, lambda is nothing but dq by this, I would say dx, if we talk about this dx. Understand? In this case, what is this lambda? This lambda is nothing but charge per unit length. Understand? On unit length, how much charge is present? On this length, how much charge is present? I have discussed this previously in the starting of electrostatics. How much charge is present on each unit length? Understand? So this is nothing but lambda is equal to dq by dq. Can I found from this dq will be nothing but a lambda times of dx in this case? So just put it over here. So dv will be nothing but k lambda dx upon this x. Now you will say, sir, why are you exactly doing this? Why are you exactly doing this stuff? Means changing this dq in terms of lambda dx. We cannot integrate. See, what we are supposed to find afterwards, we need to integrate this one to find the total potential because of this entire rod. We cannot integrate this dq with respect to this x with respect to this what do we say, this dq. Understand? Because x is variable over here. We need to find from this x to this x. Understand? That's why we cannot integrate it. That's why we are changing this in terms of dx only, in terms of x only. So now, can you tell me the total potential? So this total potential will be nothing but integration of this. That will be, so integration of this k lambda dx upon this x exactly. From where to where? We say over here it is nothing but L. Over here it is nothing but how much? Over here it is nothing but r. From this point this is r, and at this point this is r plus L. Understand? So can I say it is nothing r from r to r plus L exactly? So it will be nothing but take this k lambda, both are constants, take this out. So it will be integration of 1 by x from r to r plus L. This will be dx. Can I just write it will be k lambda? It is nothing but 1 by x, integration of 1 by x, that is ln of x. So you can definitely, that is ln of this x from r to r plus L. So it will be nothing but k lambda. First you put this one, ln of x minus ln of r. That will be ln of r plus. First you put this, ln of this r plus L minus ln of this r. Okay. So that will be eventually ln of this r plus L by ln of this r. So ln of this r plus L upon this r only. So this will be the potential due to this entire rod. Fine. No. You just don't need to derive these expressions. You just have to learn the concepts. I'm basically trying to show you. See, I'm elaborating this over here. This is just the one line step, okay? One line concept. So over there, if you are supposed to get this, this was even asked in JEE, okay? This was asked in some JEE directly, this question. What is the electric potential due to the charged rod? Like something like JEE mains 2017-18, something like that, directly asked this question. So in that case, this is the one line step. I am just elaborating it in order to make you understand, okay? You just know, you should try to basically know what is the concept behind this. How can we basically derive this expression? It is not going to take this much of time. It'll just take 3 seconds, even if you have to derive this also. Tomorrow is the class that is projectile motion. Lecture 1, in that we'll be covering entire angular projectile and some of the previous year questions. See, remembering formula is sometimes, see, physics is not the thing, physics is not the subject in which you have to remember the formula and they will be basically asking, giving you the values and you need to put all of those values in that formula and you will get the answer. Physics is not like that. You have to, physics is what? It is more of application part. You have to basically use the concepts in the problems. Understand? That questions will be asked in your JEE. Understand? Not in NEET. I'm talking about the JEE. So for that, you have to learn the entire concept. For that, you have to learn what is the method of solving the concept. How you can use the concepts in the problems. Understand? That is the main point that you are supposed to use in this one. It is not something like that, like you find in chemistry, there is a formula, values are given, put that values in the formula and you'll get, you have to learn the entire concept. That's why people feel this is a bit difficult. Electric potential due to a charged ring. At its center, can you tell me how much it will be exactly at its center? You will say, sir, it is 0. This is a scalar quantity, okay? I forgot to tell you, this is a scalar, this is not a vector, okay? So if this was vector, because of this charge at this point, it will be something like this. Because of this charge, it will be some, so they will cancel each other, eventually it will become 0. Like previously we were talking in case of the electric field, but this is a scalar. So all of these will add over here. So if I take, for example, this is a charge dq over here, this is at r distance. How much will be because of this at this point? How you can find, take the charge from infinity, that is the procedure I'm directly now saying. So this will be nothing but dv is nothing but that is k dq by this r. Understand? If you want to find the total potential, take this dq. Because of this, find this one. Add all of these dv's. So integrate now. Integration, that will be integration of k dq by r exactly. This is constant, r is constant because r is same. Take this out. So this is k by r integration of this dq. So v is nothing but that is k integration of this dq, that is q by this r exactly. Kq by r. Understand? This will, we have to add up. Yeah. Yeah. Can you tell me because of this one? No, it's given over here. How can you exactly find because of this one? See, if I say, for example, take this one, okay? This dq exactly over here. This is r. If I say this is x, this is r, this is x, how much this will be? You will say, sir, this is nothing but this is r square. If you say this is r square plus this x square, root of r square plus x square. Now at this point, you will say, sir, it is nothing but dv. Understand? Because of this very small charge, it is nothing but dv. Again and again, I'm saying you don't say, if I'm saying because of this one, don't get confused. At this point, potential will be, if the charge is placed over here, how you can define the potential? Take the charge from unit charge from infinity, place it over here. See the potential, see the potential energy, divide that by charge q naught, potential energy per unit charge at this point, how much that will be? That will be the potential. Understand? Now, can you tell me, this is nothing but that is k, this dq upon r square. How much is r? That is this one, root of r square plus x square. If you want to find the total potential integrated, that is nothing but integration of k dq by this root of r square plus this x square. Now v is nothing but, this is constant, this is constant. See, this is constant for every point, for every dq, okay? Because this is a ring, okay? On its axis. And this x is also constant, this x is also constant. So we can take this out. So this k upon this root of r square plus this x square, integration of k dq. Sorry, this k is also constant. So integration of dq, that is q. Okay, if you integrate all these dq, you'll get the total charge on this one, for example, that is nothing but this q. So it will be nothing but k this q upon this root of r square plus x square. Fine. This is not something like that. You are talking about the vectors, okay? So that was an electric field. If I say at this point, what will be the electric field? You'll say, sir, that is this electric field. So this electric field will have two components, this component and this component. This you can take as cos component, you take this as sine component. Then because of this, it will have this component. And then because of this dq charge, this will have this electric field over here. So this will have two components. This will have one component. Now this will cancel with this one. We have to add all of these components and we'll get the net electric field at this point, which I have told you before. Understand? So this is what? This is a scalar quantity. Just you have to add. If because of this at this point, there will be some potential scalar. So because of this, there will be some potential. Because of this, there will be some. Add all of those, you'll get the answer. Just normal. It's very simple, okay? If you try to make a graph of this one, it will be something like this, okay? At the center of the ring, it is maximum. And from this expression also, you can find the electric potential at the center. How? See, if you are supposed to find the electric potential at this center, so x has to be basically 0. Put the value of x in this case 0. It is kq upon root of r square plus 0. So can I just write v is nothing but kq upon, what is this r square? R square, square root will cancel, this will be r, kq by r. What was the previous kq by r? Where r is the radius of this one. Over here, r is this radius of this one. Okay. Electric potential due to a uniformly charged disk. Okay, this is basically a disk over here. At this point, it is something like this. It is something like this. Okay. At this point, exactly you are supposed to tell me. This is the exact figure. Okay. This is the exact figure in 3D if I try to make on its axis at this point. Okay, at x distance. This is what we are supposed to find out over here. What are you talking about? There is a charge present on this one. What do you have to do with that? We are supposed to potential because of this one. Charge present on this one. Understand? Now see, at this point exactly, this is a disk, charged disk. Understand? Charge is present on this one. Consider this as a conductor, okay? The charge is present on this one, on this. And at this point exactly, we are supposed to find what? The electric field. Sorry, this electric potential. How we can exactly do this one? See, what I suggest you to basically take a ring over here, cut a ring exactly. Okay, so when you, this disk is basically made of different number of rings. So from here to here, there are so many rings. So we'll cut a ring. So because of this ring, we'll try to find out the electric field at this point. So once we get the electric field because of this ring, we'll integrate this from this point to this point. We'll integrate, we'll get the we'll get the potential because of all the rings from this point to this point. So that will cover the entire disk. Okay. Now listen to me very carefully. Listen to me very carefully. See, what I'm trying to say in this case is, at this point, first of all, you take this ring. Okay, in this ring itself, you take a small charge that is, for example, dq, and the length of this one is a dr basically. Understand? So this is basically, this radius is r, and this is basically what? Capital R from this point to this point. Keep this thing in your mind, from the center to this. If I ask you because of this one, how much it will be, you will say, sir, it is very simple. That is nothing but, if I say this is R, this is X, this is a root of R square plus X square, this distance. At this point, how much will be the potential? You will say, sir, that is a dV is nothing but K dQ by how much this? This is nothing but R square plus X square exactly. Fine, this is the case. Now in this case, if we differentiate, if we integrate this one, can we integrate this with this stuff? This is dq, this is r plus x, r different, x different. So this is something different. Understand? So that's why we need to change this dq in terms of these only. So how can we find that? let me just tell you. See, this is a disk. Okay, this is some sort of sheet. Over here, there will be sigma. Understand? Surface charge density. Charge is placed on the surface. So on per unit area, how much is charge? So we can say that sigma is nothing but dq by dA. So can you tell me this dq will be nothing but sigma? See, I'm not explaining this once again because I have told you this so many times previously. Sigma, this dq is sigma dA. Understand? This is nothing but charge per unit length on per unit, or charge per unit area on per unit area, on per unit area, how much charge is basically present over there. So this we got over here. Now, if you put this sigma dA over here, still you cannot integrate. This is in terms of dA. This is dA. This is Rx. Now we need to change it more. So can you find this dA of this one? That is area of this ring. Understand? Easy. It's very easy. So if you take this ring over here, if you take this ring over here, this is the ring. Okay. This is having some width also. Okay. Now, if you cut this ring, so it will basically be a straight rod or straight wire. So this rod is having how much length? So this ring is having how much circumference? That's the length of this rod. So that length of this wire rod, whatever you say, that is nothing but 2 pi r. Understand? 2 pi r if the radius is r. Now, this is 2 pi r. How much is this width? You will say, sir, this is nothing but dr we taken initially. Dr. Can you tell me the area of this one? You will say, sir, that is nothing but length into breadth. So this dA, it is very small because this is infinitely small. So this dA will be nothing but 2 pi r. This is length multiplied by this breadth, 2 pi r into dr. Fine. Okay. Now, if you got this one, can you put it over here? So dq will be eventually, that is nothing but 2 pi r dr, and this sigma. Instead of dA, we basically put this over here. Now, can we find this dv is nothing but k. Instead of this dq, that is 2 pi r dr, and this sigma over here upon this root of x square plus r square. Now, we got basically the potential due to this one completely. Now you need to find the potential due to the entire disk. So what you are supposed to do, integrate this one. So you'll get V integration of this K sigma 2 pi r dr upon this root of x square plus r square. It will be from 0 to r because we are varying from 0 to r over here. Understand? Then only we'll cover all the rings and we'll cover the entire disk. So can we just write it? V is nothing but this is integration of, instead of this, see this is 0 to r. Can we just write instead of this, that is 1 by 4 pi epsilon naught. So it will be 1 by 4 pi epsilon naught, and it will be 2 pi r this dr, sigma 2 pi r dr, and it will be root of x square plus this r square. So this pi will cancel, 2 and 2, 2 is 4. So what we'll get, just we'll write it over here. This V will be nothing but, we can take this sigma by 2 epsilon naught, constant, and inside it will be only r by root of r square plus x square. That is r by root of r square plus x square, this dr. Understand? So this is from 0 to r. If you integrate this one, it will be nothing but sigma upon 2 epsilon naught. It will be nothing but this root of r square plus x square from 0 to r. Then if you put the values, it will be nothing but sigma upon 2 epsilon naught, and it will be nothing but, first you put this r over here. When you put this r, it will be nothing but root of r square plus x square as it is, because this, instead of this r, you need to put the first limit, that is r. When you put the second limit, instead of this will become 0, and this x square as it is, minus of this will be nothing but 0 square plus x square. So now this and this will cancel, 0 as it is. So can we just write V is equal to sigma upon 2 epsilon naught. This will be a root of r square plus x square, this minus x exactly. So this is the potential because of this charged disk. Okay. Yeah. I'll be teaching the Gauss law tomorrow. Tomorrow, not day after tomorrow. Okay, because tomorrow is the lecture for 11th portion. Day after tomorrow, entire Gauss law, entire flux. Okay, in just one shot. And you'll be getting the schedule by tomorrow itself, by today, tonight itself, okay, for the next 7 days. Let's go for this one. Relation between electric field and potential. What is the relation between electric field and potential? I told you previously, listen to me very carefully. I told you previously that if you need to define the electric field at a point, if you know the potential, you can define the electric field at that point. Or you can basically understand it like this. If electric field is given, if potential is given, can you find the electric field? Yes, because there is a relation between these two. Like we have, you might have studied this. If velocity is given, if you are supposed to find acceleration, you go with dv by dt. If acceleration is given, you are supposed to find velocity, you do the integration. That is delta v is nothing but integration of a dt. So this is the relation between these two. Same is the relation between this electric field and this potential that we need to discuss over here. Okay? Yeah. Now, listen to me very carefully, all of you. I'll be showing you this in detail. Don't worry about that. This is the electric field, this one. So there are two ways you can basically understand. If I say at any point, what is the value of potential? You will say, sir, it is very simple. That is nothing but V is equal to KQ by R. This is the formula for potential, or you can write 1 by 4 pi epsilon naught Q by R, whatever it is. If I ask you to differentiate this one with respect to the position, understand, with respect to R. So you'll say this is a dV by dr, understand? So it'll be nothing but this. See, this 1 by 4 pi epsilon Q, it will come out, or this KQ, 1 by 4 pi epsilon naught constant, this Q also. Now differentiation of this R, differentiation of, this is the constant, it will come out, differentiation of this 1 by R, it is minus 1 by R square. Very simple, na? So this will be dV by dr exactly. It is equal to nothing but, you tell me, this is nothing but minus, this is K, this is K. So this will be minus K, this Q upon this R square. What is this KQ by R square? Electric field at a point is what? If I say this is a charge, because of this charge at this point R distance, what is electric field? You'll say, sir, that is nothing but KQ by R square. So what is this? Nothing but electric field. So can I just write this electric field is nothing but minus this dV by dr. That's what I was explaining you. If you know the potential at a point, you differentiate that potential with respect to this position, you will get what? Electric field. That's why I was telling you in the initially, this electric field at a point can be defined either by electric field intensity formula or by potential also. Means if you find the slope of this potential, that will give you the electric field. If you differentiate this potential, that will give you the electric field. Rate of change of potential with respect to this position is nothing but electric field. Okay? So we got this relation over here. Everybody understood? Come on. Yeah. If you know the concept, everything becomes easy. So this is basically this one. Or you can basically call it like the another way to derive this one. You say velocity, this potential is nothing but that is potential energy per unit this charge. Understand? Now if you ask you, tell me change in this potential, you will say that is nothing but this, that is a du upon this q naught. What is this du? Change in potential energy or potential energy stored. When you take it from that charge from infinity to that point, potential energy stored. How that is stored? Work done, whatever the work you have basically done, that is negative of work done by conservative forces or electrostatic forces. Understand? Upon this q naught. Can I just write it like that? Now what is this? Can you write this minus of dWe? What is that? Work done by electrostatic force. That is electrostatic force multiplied by the displacement. So F electric multiplied by this dr upon this q naught. F by q naught. What is that? F by q naught. Electric field is nothing but F by q naught. So this is nothing but electric field. You can definitely, this is nothing but, instead of this I'll write electric field E and this dr exactly. So finally E will be nothing but minus dV by dr. Fine. Either you go with this, either you go with that, it's one and the same thing. Now, there is another formula that I need to tell you. See, if I say, for example, E is equal to minus dV by dr. So means, if a potential at a point is given, if you find the slope of that potential, you will get electric field. Now, if electric field is given, can you find the potential? Very simple. So can you basically transfer it over there? So it will be dV is equal to, that is minus E dot dr. Can we just like write it like that? Now, if you want to find the total potential or change in potential that bigger, so you will definitely write integration of this one, integration of this one. So that is delta V is nothing but minus integration of E dr. That's why I'm telling you, electric field is given, you need to find the potential, you need to integrate. It is same as this. If velocity is given, you need to find acceleration. What will you do? That is A is equal to, you will differentiate this velocity. You will find the slope of velocity. Same is the case over here. What? That if potential is given, you need to find electric field, differentiate this one, find slope, you'll get that. If acceleration is given, you need to find the velocity. What you will do? You will basically, acceleration is nothing but dV by dt. Take it over there. So dV is nothing but a dt. If you want to find the change in velocity, that is delta V. After integrating this one, integration of a dt. Same exactly over here. I hope you're getting the feel. Okay. So remember these formulas. These are very important formulas. This one, because it will eventually help us. Okay, now let me just write this in a Cartesian form. After that, we are done with this one. Okay. Okay. One second, I'll just add the slide. 7. Why is it lagging exactly? Taking so much of time. Okay. Okay, let's move on to this one. Now, can you just write exactly this formula? Okay, I'll just show you this in Cartesian form as well. This formula, where is that? This dV is equal to E dot dr. So this dV is equal to minus this E dr exactly. Now, if I ask you this electric field, write this electric field in Cartesian form. At any point, electric field in x direction, I, j, k cap, okay? So you'll write E is equal to, at any point electric field, this is a vector in x, in y, in z. So you'll write, sir, electric field in x into I cap plus EY into j cap plus EZ into k cap. Fine. Afterwards, if I ask you to write this position vector in terms of that only, you'll say, sir, this is xi cap plus yj cap plus z k cap exactly. Now, if I ask you to basically tell me dr, change in this one, so you'll, sir, this is nothing but d of xi cap plus d of yj cap plus d of z k cap. Okay, now put this in this one. So we can write this dv is nothing but, change the color, we can write this dv is nothing but this, instead of this negative as it is, we'll just write, instead of this E, we'll put this one. That is because we are supposed to find this in Cartesian form. This is E of x into I cap plus E of y into j cap plus E of z into k cap exactly multiplied by this dx into I cap plus dy into j cap plus dz into this k cap, just plus dz into k cap exactly. Fine. Now, afterwards, solve this one, this with this, I into I. So can we just write, this is nothing but negative as it is. This will be E of x. I hope your vectors is clear. E of x into d of x plus this E of y into d of y plus this E of z into d of z exactly. Finally, if you multiply this with, so it will be minus of E of x into d of x minus E of y into d of y minus E of z into d of z exactly. Fine. So we got this one. We got this one. I hope everybody is able to understand this one. Come on, do let me know in the live chat. We need to do some of the problems on this. That's why I'm showing you this over here. Now, so we got this one. So finally, if we got this exactly, I want you to partially differentiate this. What is the partial differentiation? Now that is the point. Partially differentiating this one means, see, if I ask you to partially, you'll get to know this in the engineering, okay? If I ask you to partially differentiate this with respect to x, means you are differentiating this entire equation with respect to x. In that case, this y quantity, this ey, ez, this whatever is in the y, z, this we need to take as constant. If I ask you to partially differentiate some equation, for example, E is equal to x plus y minus plus 3z. If I ask you to partially differentiate this one, so partially differentiating this one with respect to, for example, x, so means in that case, y is taken as constant, z is taken as a constant. So in that case, the differentiation of this one will be dy will be 0 because differentiation of constant is 0. So dz will be what? 0. It is y partially differentiation where a dou y, dou z. Differentiating partially, okay? Now over here, if I ask you to partially differentiate with respect to y, in that case, this is taken as constant, this is taken as constant. You'll get to understand this one. So over here, if I ask you to partially differentiate this one, so how can we exactly do that? Listen to me very carefully. After some time, you'll get to know why are we exactly defining this. Yeah, exactly. Yeah, first differentiation with respect to x, y as other as a constants. Okay, if I ask you to partially differentiate it with respect to only x only, then others are taken as constant. Now, if I ask you to partially differentiate with respect this also, with respect this also, so first you take these two constants, then you take this one as, then you take this and this constant, then in the third case you take this and this constant with respect to when you are doing it with respect to z only. Okay, that's great. Now, if we exactly do it over here, can we just write this will be dou v by dou x exactly? First, we are differentiating this equation partially in terms of x with respect to x. So in that case, can I just write this will be what? This will be exactly, can I just write it will be nothing but we are partially differentiating this one with respect, it will be nothing but e of x only. So this will be minus, what this? We are differentiating this. This will be, can we take this exactly as constant in that case? So we need to basically take this as 0. Everybody is able to understand this one. Come on, I need to know in the live chat. There is a guy, are you an engineer? You'll be studying this when you go in engineering, like in first sem or second sem, you'll be having this. Yeah, Laplace, everything, okay? Now see, so in that case, can we say this is nothing but we'll take this as 0, we'll take this as 0 over here. So E of x is nothing but minus a dou v by dou x. So means if you are supposed to find the electric field in x direction, in that case, you need to differentiate this partially with respect to x. After some time, I'll show you the equation. In that equation, you'll get to know how you can exactly find that. So we got this ex. Similarly, we can find this ey. Understand what that will be? In that case, this is taken as constant, this is taken. So differentiation of this 0, differentiation of this 0. So can I just write in that case, e of y will be nothing but that is minus dou v by dou y. And similarly, E of z will be nothing but minus dou v by dou z exactly. Okay? Okay. That's great. Yeah. So we got finally this one. Now you can put this over here. After this, we need to basically sum up the problems. That's all. We got done with this. Okay? So put it over here. which equation? In this equation you can put it. That is E is equal to this E of x into I cap plus E of y into j cap plus E of z into k cap. Exactly. So E will be nothing but over here, that is minus this dou v by dou y, dou v by dou x, dou v by dou x into I cap plus minus only because this is having the negative sign, be minus dou v by dou y into j cap minus dou v by dou z into k cap. Exactly. Okay, fine. Now you will have question on your screen. I want you to tell me the answer of this one. Come on. OMK hype, can you give me the answer of this question? Okay. So the potential at a point is given 4x minus 2y plus z. You are supposed to tell me the electric field and magnitude of electric field. Tell me. How much it will, how can you exactly solve this one? You are supposed to tell me the electric field. You are supposed to tell me the electric field. Okay. We know this electric field is nothing but, understand, at any point, electric field, it can be in y, x, z, I, j cap, whatever it is, we don't know. Okay. So we know this formula. Okay. We know this formula. If you are supposed to find the electric field at a point, potential is given. Over here, potential is given. So what you are supposed to do, you partially differentiate that with respect to x, you will get that x coordinate. You can understand it like that also. Then you will get this one, then you will get this one. Put it over here, you will get the answer. Okay. So can we use this one? That is nothing but minus dou v by dou x into I cap plus minus only minus dou v by dou y into j cap minus dou v by dou z into k cap. So over here, can you tell me, first you partially differentiate with respect to x, you will get this. Then with respect to this, you will get this. Then with respect to z, you will get this one. So can you partially differentiate this with respect to x? That is this dou v by dou x. Can we? These we can take, we need to take basically as a constants. So in that case, this will be nothing but that is 4 only. For this, it will be 4. Differentiation of this will be 4. Exactly. You can take this dou v by dou y. How much that will be? Minus 2. Dou v by dou z, how much that will be? 1. Now put this over here, electric field is nothing but that is minus 4 and this minus of this minus 2, then it will be this minus of this minus 1. This is I, j and this is 1, this is k. So electric field will be nothing but 4I plus 2j minus k. Check it if I'm doing it correctly. Okay. So you got the electric field. You got the electric field. Okay. Yeah. You got the electric field. Now it will be nothing but mod. You need to find the mod of electric field. That is nothing but root of this 4 square plus 2 square plus 1 square. It is root 2 1. Okay. Everybody else. Okay, this is the another question. Can you tell me the answer of this question? Yeah. Can you tell me the answer of this question? Come on. Now electric field. Previously potential was given. You were supposed to find the electric field. Now if electric field is given, you are supposed to tell me the potential at x comma y. If potential at origin is 5 volts initially. Now you tell me how can you exactly do this one, as I was explaining you that formula previously. Electric field is given, you are supposed to find the potential. What is that formula? See, we know electric field is nothing but minus dV by dr. Fine. Now if you are supposed to find potential from electric field, take it over there. So it will be dV is equal to minus E dr. Understand? Now integrate this one, integrate this one. So you will get that. So can I just write this is nothing but del V is nothing but integration of minus E dr. Understand? Now first you integrate it with respect to x, you'll get that x. Then you integrate it with respect to y, then you will get exactly the answer of that. Okay. And over here you need to basically put this one second, directly put the limits. So this is integration of this dV. It is saying that potential When at origin means at x is equal to r is equal to 0. In that case, it will be potential was 5 volts. Understand? And after some time, for example, at r distance, its potential is, for example, this V. Yeah, exactly. You need to integrate this. Somebody is saying session for Gauss law, session for that, session for dipole, session for that. First, you come in these sessions, then only we'll talk about the other sessions as well. Every session is gonna come. Fine. So what you are supposed to do exactly over here is, this will be nothing but integration of this will be v minus 5. So it will be v minus 5 initially. Okay. So now integrate this, integration of this from, this is e, that is 2x plus 3y, exactly dr from 0 to r. Now with respect to x, with respect to y, because at x comma y we need to find this one. So v minus 5, it will be nothing but integration of this 2x dx from 0 to x, because this is from 0 to r is x comma y. At x comma y we need to find. So I hope everybody is able to understand, because this is very simple. Okay, so this is from 0 to y, and that will be 3y dy exactly. So can I just write v minus 5 is minus, this will be 2x square by 2. When you put the limits as x, it will be only this one, plus this has to be minus only because this is minus 3y square by 2. When you put y over there, it will come as it is. So finally it will be, that is v is equal to this minus x square minus 3y by 2, y square by 2 plus 5. Check it if it is correct. Okay. So ladies and gentlemen, this was all about today, and it is 7:57. We are done with the entire potential and this, all the things. Okay. Now I hope you can solve all the problems from this one itself. Okay, that's great. OMK hype, where are you from? So if you got any sort of confusion in this at any point, just watch the recorded one at repeat. You'll definitely get to understand everything. Okay. Last questions, they were only the integration only. Okay. Yeah. Okay, that's great. So apart from this YouTube platform, we have our own platform. That is what we call the Unacademy's platform. Over there, you can take this plus subscription. Understand? In this plus subscription, country's top educators are teaching you. Okay, you can check it out. Okay, before taking this plus subscription, you can visit Unacademy and you can search how many number of educators are, because there are free courses available as well. So you can basically search every educator over there. How many number of top educators who are teaching you over there, completely everything is over there. You can check it first before taking this plus. Okay, so over there, what are the benefits you get plus in this plus? That is live classes, weekly tests, structured courses, unlimited access. Means you can watch anybody's lecture, any teacher's lecture, any damn time. Understand? And in this iconic subscription, you will be getting all the benefits you get in plus and some of the other benefits as well. That is the personal guidance, test analysis, experts guidelines, study material, study planners. So this personal guidance means you will be given an educator who will be helping you throughout your exam, how you can exactly crack the exam. If you have any sort of doubts, you can ask him related to anything. He'll definitely guide you. And the second thing is test analysis. Once you are done with your test, okay, after that, you have to basically analyze your scores, in which portion you are lagging, in what portion you need to basically focus more, on what chapter you have to basically work more. So that is what is done by our experts only. They will tell you, they will help you. Experts guidelines, how you can exactly crack the exam, what are the tips, what are the strategies that is given over here, study material, study planners. And you can definitely follow me on Unacademy. This is my username, Yawar Manzoor. These are the batches which are about to start, and some of these batches have already launched. You can definitely join these batches in order to boost your rank in your upcoming JEE, because top educators are definitely teaching you over there. Now, very important thing, you can take this plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. Okay. And EMI options are also available over here. Okay. Means you can pay it monthly as well. You don't have to pay the entire amount at once. And if you want the maximum possible discount from this one also, you can use my code in order to get the maximum possible discount. So this is the price for 18 months. So you can use my code in order to get the maximum possible discount. This is my code definitely. And by taking this iconic subscription, iconic, you'll for 12 months it'll be for 58,500. For 18 months it'll be for 72,000. For 12 months, 24 months it'll be for 90,000. So you'll be definitely getting the maximum possible discount if you use my code. There is something which is a massive surprise coming up for you if you are aiming for a drop. So wait for that. You'll get to know after some time. And this is a beautiful feature on Unacademy, that is ask a doubt. Understand? If you have any sort of doubt on any damn thing, understand, what you people are supposed to do is, there is a beautiful feature that is available in Unacademy Plus. So you can ask unlimited number of doubts. Whatever the doubt you have, you can ask. Our educators will give you the video solution of that doubt, that too in high quality in English language as well as in Hindi language. Okay, fine, because our educators are waiting over there for your doubts so that they can clear all of those doubts. You can ask the doubt anytime. Understand? In the morning, evening, afternoon, whatever the time suits you, you can ask the doubt. Okay. And you will receive the exact answer of that question. Understand? And you'll get this assistance with homework as well. And now the question is how you can ask that doubt exactly. So in Unacademy app, you have to basically go into this doubts and solutions. Once you take the plus subscription, afterwards you'll be getting this option over there, interface. Over there you need to take picture or choose it from the gallery. Okay, if you have in the phone, make sure that image is clear, it is not blurred, so that our educators will be able to see it very properly. Afterwards, what is the next thing? You need to crop that question. You don't have to send 5 or 6 questions at once. You need to crop that question, particular question for which you want to basically you want the answer of that. Understand? And you need to basically choose the subject of for example, if that question is under physics, so you need to basically select that this doubt is for physics only. Okay, after that you'll receive the solution very soon. Okay, these are some of the do's and don'ts while you need to basically ask any sort of doubt. Understand? That is, post only one doubt at once. You cannot post so many doubts at once. You can, once you get that solution, afterwards you'll get the another. Post clear and legible images. Okay, and you can definitely read it out, what protocols you are supposed to follow in order to basically take that. Okay. And thank you so much, ladies and gentlemen. It was nice interacting with you people. Okay, that's great. So thank you so much, ladies and gentlemen. It was really nice interacting with you people. And subscribe to this JEE English Unacademy, because we're coming up with so many courses in the upcoming time as well. So hit the bell notification button, like this video, share this video with your friends. Thank you so much. See you. Bye-bye. Very soon. Tomorrow we'll be coming up with some of the beautiful problems, PYQs from projectile motion as well. Thank you so much. I need to end this.